Welcome to Avnet Silica's We Talk IoT. We'll chat with innovators, experts and business owners to learn how they are implementing IoT and using data to create new business opportunities. I am your host, Stephanie Ruth Hader. Ski resorts lose millions to ticket fraud each year. Traffic authorities struggle to monitor vehicle occupancy. Industrial manufacturers miss critical defects that human eyes cannot detect. What connects these challenges? The need for intelligent vision systems that work in real time. And my guests today tackle these problems with AI-powered cameras that process video on the edge. Tommaso Scuccato and Marco Bergamin from Videam bring backgrounds in aerospace and automotive engineering to create smart vision solutions. Their patented algorithms run directly on cameras, eliminating the need to transfer sensitive video data to the cloud. So from ski passes to smart cities, their technology demonstrates how edge AI changes what machines can see. I'm really excited to have you two on the show today. Tell us about yourself and what it is you do at Videam.
Thank you so much for the introduction. Yes, I'm Tommaso Scuccato, one of the co-founders of Videam, that is a startup specialized in artificial intelligence and computer vision solutions. We basically have many solutions in different aspects, starting from ski resorts to smart cities, in which we can tackle using AI real-world problems. Marco is my colleague there.
Yes, I'm Marco Bergamin. I've been working in Videam for like 2 years, almost since when it was founded. I'm basically a embedded system engineer. So I have experiences in many fields, like, for example, in automotive and in communication, and also in the industry, because I have a past, an history also as a PLC software developer. And now I'm working here in Videam, integrating AI in embedded devices.
Starting from the ski resorts, that maybe it's the strangest solutions that we have up to now. Mm-hmm. Basically, what happens, ski resorts sell ski tickets to users, and these ski tickets are personal. So basically, you should not transfer these ski tickets to multiple users. If you buy a seasonal ticket, you are supposed to use it from the beginning to the end of the season, and do not, if you don't go to the mountains one weekend, you cannot borrow to your brother or your cousin.
Sure. Oh, you cannot share it, right? And they ski on your pass. Okay.
No, this is not allowed. It's forbidden. But it's an issue that it's really frequent in the domain, and it's not easy to tackle because resorts have multiple points of access. There are multiple lifts. They are spread around, and also users like operators of the resorts and of the lifts have much more important stuff to do, like checking that kids sit well in the lifts. So they do not have the time to check if who is skiing is actually the owner of the ski pass. And this is what we try to tackle. We know the issue. I'm a ski instructor, so I know this topic from the really beginning. Many years before, there were the technology to solve it in a clever way. And we patented an algorithm that using cameras, every time the users pass through the gates where they scan their ticket, a picture is taken of the full body, so a low resolution picture of all the skiers that is passing through. So we do not focus on any biometrical data, so no facial recognition. Also because in the ski domain it's not possible, because users have goggles, face covers sometimes. So basically you cannot focus on details of the person. So using these basically full body images, we are able to link all the pictures of the skiers during the passages through the gates. We link these images to their ticket, and we basically check if the overall aspect of the person remains stable during the usage of the ticket. And we alert backend validators when we suspect a fraud. So they can take actions remotely, not at -10 degrees in the slope, but in a cozy office, and they can decide what to do. And this solution, it's really spread now, because after just 2 years, the past winter, we monitored resorts in the US, in Canada, in Spain, of course in Italy, in Austria, in Czech Republic, and also during past summer, we also covered the southern hemisphere because we had an installation in Argentina as well.
Terrific.
So, yeah.
And when you founded the company, was that the problem you were trying to solve, focusing on the ski ticket fraud, or what problem did you have in mind when you started the company?
When we started, actually, we had in mind to basically develop vision solutions using AI. And we understood that to be able to tackle really complex problem, because that is where we wanted to go as a company, we needed a hardware solution that was basically proprietary, so we would be able to deeply customize it. That is the first driver of the company when it was founded. But actually, after just, let's say, few months, we had this idea in mind. We started more or less like a game. We proposed a patent, we proposed to customers, and actually this thing drove really fast because everyone was really interested in it. The patent went on smoothly. We were able to do some partnership with big companies to promote the solution. And so basically this became a parallel project, but then we were able also to integrate that project in our smart camera. That was the main objective of the startup itself.
You both come from backgrounds in aerospace and automotive, if I understand it correctly. How did that experience shape your approach to AI vision systems?
Basically, yes, we both came from aerospace domain. I'm a telecommunication engineer. I started during the last period of my university, and also for a few months after. I was working mainly in design and understanding of signals, mainly for planetary observation missions. I also had an internship at JPL in Pasadena, where I was involved in the development of radar sounder. That is a particular type of radar that goes below ice and tries to understand if below the ice there is liquid water. Then we moved to navigation satellites. So basically developing and studying new signal designs for mainly Galileo satellites, working with the projects. That background helped us find the best technology and products and design it in a clever and precise way.
Yes, in my case it's quite different because I started with computer vision during my master thesis. And then during my very first job, I developed an application based on computer vision to do quality checks inside a machine that was producing special cables for example, aerospace applications. So there was these very tiny cables with many layers. And during each step of the production, there was a camera with an algorithm that was checking that some parameters were within a given range. But it was almost 10 years ago, let's say, classical computer vision, because the AI was not yet a thing like it is now. And then my experience with automotive were also useful for designing embedded devices for the Internet of Things, but they were not very related to AI. Let's say that I had to study it almost from scratch in the last 2-3 years.
Now we mix IoT and AI.
So you have patented your algorithm, and you mentioned that you don't use facial features for detection. So how does it work?
Basically, for that particular topic, we look mainly high-level features that are not unique to a person, mainly color patterns of suits that, because for that particular domain, that is ski resorts, usually users don't have multiple ski suits. So usually they have a few, and we were able to tackle this problem linking to a ticket ID, one or many profiles of the skier. For example, when I teach ski, I have my ski instructor suit. When I go skiing on myself, I have another suit. In my case, if the algorithm propose my figure and my ticket as a potential person that swapped the ticket, just with a simple button, the operator is able to say, no, algorithm, look that this ticket ID is linked to a user that have two suits. So basically, now it is in the system, and anytime I use any of the two suits, I will not be notified anymore. So yeah, that it's a logic that we tested in the field, and it's really powerful.
Yeah, it's really cool when you talk about facial recognition, that obviously in a skiing context, you already have the issue if it's a sunny day, the person wears sunglasses, if it's really snowy, big goggles, and then it completely changes the whole image.
Exactly.
Yeah,
So we
really
basically
cool.
Do not look at these features because they are not meaningful to distinguish between people. We look at features that in the context don't change often.
You decided to choose to process AI on the edge rather than in the cloud. Why did you do that?
Basically, this solution of processing AI on the edge has many advantages. First, security. For example, smart city and license plate recognition. The final users do not want to upload images or videos in the cloud of third-party systems because you cannot have the certainty that these data do not train some algorithm without knowing. So having the processing all inside the camera and notifying only the final events solves this issue. Then there are other issues like responsiveness. We can do AI in real time. For example, in our smart camera for traffic application, we have many algorithms that runs in parallel. We have object detection algorithm, we have classification algorithms, we have OCR algorithms that all run real time. The slowest one runs at approximately 100 frames per second. So we can basically immediately produce beta events that we have also a cloud solution that can be installed in a cloud or on-prem of the users that collects all this data in their servers, and we integrate it also with their systems. For example, if they have some internal databases where they have a list of blacklist plates, we can, on the fly, as soon as the event of a new plate being created, we can immediately check, connecting to their systems, if this is a blacklist, if the plate is in the blacklist or not. And we can produce complex solutions and notifications based on all these aspects. So this, and another aspect is, let's say, also cloud, it's really also energy greedy, so we are able also to perform everything with a few watts of power. So yeah, there are many advantages in our solution. And also traffic consumption, of course, sending event of the small string of the plate being read instead of sending all the video stream, it's much more cheap on the data transfer side.
I would also say that in particular for computer vision application, it is practically mandatory to process the data on the edge because, for example, one 5 megapixel sensor can produce, for example, few hundreds of megabytes per second of data that cannot be sent somewhere in the cloud due to limitation of the network. So for this reason, we are seeing every year new processor that can process more efficiently the data from the cameras using NPU, neural processing unit, that can consume like in some cases also less than 1 watt. So this, let's say that with the cloud architecture, you can do something, but on single pictures, not on videos, in my opinion.
What limitations of existing camera systems did you encounter? Why did you choose to build your own?
Well, we wanted to have the maximum flexibility because at the beginning we had many ideas and we wanted to be sure that we could do everything with the hardware. So we wanted to develop our hardware based on our requirement. And for this reason, we choose a platform from AMD, which is the Crea K26 system on module, which is basically a system on chip with an FPGA. And this gives us the possibility to implement our ESP, the little unit that are able to process the raw data from the camera sensor. And also we use it for accelerating some algorithm, for example, the AI algorithm, and give us also the possibility to implement very fast tasks. For example, me and Tommaso, we have a background in the GNSS industry. So we put also a GNSS module in our camera and implement an hardware feature to connect the PPS out of the module that give us the time synchronization very accurate to the trigger of the input trigger of our sensor module. This can allow us, for example, to synchronize perfectly different cameras and also to implement some, for example, stereo vision algorithm technique on different cameras that are not physically connected. This is one of the possible features that we could implement with our hardware. And we can also design it to be future-proof because the initial application is related to the traffic, basically data recognition, vehicle classification, and so on. But we would like also to enter in the quality control field in the automation sector. So for this reason, we have already implemented some interfaces like, for example, the RS8485, the CAN bus, and beside the standard Ethernet connection. So to be ready also to allow our camera to communicate, for example, with a PLC in a production line and to exchange data. This is basically the reason why we wanted to have the complete control of our hardware.
We can accept up to 4 video streams with 4 camera modules. So we can also check objects if we stick to the industry control from many angles. And basically perform either stereo, triggering the capturing of the images from 4 sensors from 4 different angles and process all of them in real time in our hardware. And of course, as Marco said, connect to industrial interfaces if we have to put our system in more complex systems of the customers.
Yeah, let's maybe dive into some more use cases. So ski resorts obviously is one where you can relate and understand really easily how it works. But I heard from you that it's also possible to use it for traffic control, for maintenance purposes, or for industrial use cases as well.
Yes. Basically, we can really quickly sit with the customer and understand the issues in their production line that can be solved with vision algorithms, and we are able to define a proprietary artificial intelligence model that identifies, for example, defects or classifies good objects with respect to bad objects, sitting with them and understanding what is good and what is not good for their particular industry. Usually for traffic use global shutter sensors, but we are also using now a polarized sensor that is also able, we use it both for traffic applications and we can use it also for industrial applications, because in front of each pixel it has a polarized filter with different degrees of polarizations. So from a single, let's say, capture, you do not have one single image, but you end up with many images, everyone with the different polarization angles. And then we can combine these images in a clever way to identify also defects and aspects that are not visible. For example, for traffic application, we used to remove reflections from windscreen, and so we can also perform some inside vehicle applications. For example, there is a big demand in the market for cameras that are able to check if people uses their phone while driving. Now it's one of the most dangerous things that drivers can do. It causes many incidents. There is a lot of attention from our final customers to that topic, and with our solution, we were able to tackle this aspect using this sensor, and we produced basically a camera that is really easy to install, because regardless of the hour of the day, you can completely remove the reflection from the windscreen and see in a sharp way the people inside the car. And as I was mentioning, also in industrial, this sensor can be used to identify defects in lenses, in glass production, in plastic production, in industries where basically these additional information coming from images at different polarization angles can be injected in artificial intelligence algorithms to identify features not visible with a normal sensor.
With the windscreen, the problem was that you could not see inside the car, because once the sun hits the windscreen, a camera would not be able to identify if there's a person inside. In the future, there's no more excuses. It wasn't me, or I was just scratching my cheek.
Yeah, exactly. No, that is solution. It's really, that problem is really complex to solve in a different way. Also because you can use, of course, a polarized filter, like the professional photography ones, but you have to manually adjust depending on the hour of the day, of the surface that you are framing. But with that particular sensor, we removed all the manual aspects of removing the reflection, and we can do it regardless of the surface that you're framing, regardless of the hour of the day, regardless. So it's really easy to solve the solution with our product.
And just to rephrase, the polarized sensor works in a way that basically you take multiple pictures and then by putting them all together, just removing the glare. That's how it works?
Yes,
in
exactly.
Simple terms?
In simple terms, that's what we do.
How important is backwards compatibility to your customers?
It is important.
We are helping our customer to migrate to cloud solution, aggregate data from heterogeneous devices. We are also able to take the proprietary protocol of a third-party supplier and convert it on the edge using a bridge that we design. to enable older devices that doesn't support, for example, MQTT or secure authentication, to communicate securely with our new cloud infrastructure. So we can help them to migrate older system to a new infrastructure using edge devices, basically.
So we can basically import and augment the capabilities of hundreds of cameras that are already installed, that may be too costly or too complex to change to ours. So we can basically start a customer that wants to install our cameras because of our solutions. They don't have to change all of the systems that they have. But basically we can provide really small devices that augment their products to the new solutions that we provide with our camera itself.
Mm-hmm. Where do you see the biggest opportunities for artificial intelligence vision systems in the next years?
I think that we will see many more smart devices in the near future because there are many applications and problems with a clever idea. They can now be solved with a smart camera. For example, the ski industry, if we take our solution as an example, it was a lifelong problem, but we were the first ones that solved it with artificial intelligence, and we did it really well. So there will be many more examples like ours in the future. So we think that if we are able to provide a platform that can tackle this, we have the capabilities to solve these problems in a clever way. So we expect that in the near future there will be many more devices like this. Mm-hmm. We are also developing a new hardware with different ideas in mind. I don't know, Marco, if you want to explain a bit.
We went in last December in a workshop organized by Avnet in Padua, where they presented a new microprocessor with the built-in AI accelerator, which was very interesting to us because it was powerful enough for our applications, and the power consumption was also very low. It doesn't even require heat sink to dissipate the heat. It is the new STM32 MP2 system chip. Mm-hmm. We were very interested in this application. Right after the workshop, we tried to buy it, and we were able to have the first development kit in the following January after the Christmas holidays. And we started to develop a smaller camera for tailoring application that maybe don't require all the flexibility that can be addressed by a powerful FPGA, but they can do, for example, object detection, object recognition, and other simple tasks. Since we were one of the first, I think, at least in Italy, to use this hardware, we found some software-related bugs, for example, in the Linux kernel, in the proprietary driver, etc. Thanks to Avnet and also ST, we were able to speak directly with the engineering team who developed the board.
Cool.
And now we are proceeding with this development. We are very happy with the support that we received, even though we are a small startup. Mm-hmm. We were helped a lot.
Yeah, sounds really cool. If any of our listeners now has an idea and wants to bring their AI vision system to life, what advice would you have for them?
I think that the first thing is to find a nice development kit, well documented, and to read carefully the documentation. first of all. And to not be afraid to try it, to propose it to people that may be interested, because you never know. The project related to the ski pass was started as a toy, more or less. But when we had the opportunity to try with some ski resort owner, we understood that it was very necessary for them to have a system like this. And within a year, we had already our deal, our partnership with a big company that is providing the infrastructure to the ski resort.
There are many applications and problems that can be solved with AI and vision aspects. Of course, the biggest issue is knowing these problems. The issue of the ski pass, it's known only to people of the field. And usually it's not easy to know these problems for people who can solve the problem in a clever way. I think the link of people with technical background and solutions as ours can solve these problems with the people that actually have problems to solve and they think can be solved with these solutions. It's really important. I think it's really good also the work and the job that Avnet is doing in organizing workshops, to putting together all the field application engineers, that their work of going to customers and their work of linking technology producers and suppliers as us to customers that may have issues but do not have the product to solve it, or the, let's say, background to solve it. I think it's really important and basically it's helpful for everyone, for us, for the final customers, for Avnet itself, so that we can produce thousands of cameras.
Fantastic. Yeah, that's a great summary for this whole episode. Thank you. If you had to put together a playlist for this episode or for your project or your company, what song would you put on it?
Marco, do you have ideas?
Don't Stop Me Now, Queen.
Very
Yes.
nice. I don't think we had that yet. So is there anything I have forgotten to ask you? Anything you would like to add, or have we covered everything?
We are also developing a camera enclosure with targeting high-level applications and areas where also design is kind of a matter. I have a really close friend of mine that is a product designer, really a really good one. He just won Salone del Mobile at Milan. He just won another international trophy in New York. That, I mean, a really close friend. So we said, oh, but why don't you design for us a camera enclosure that we can install everywhere? We can install in museums, we can install in the ski slopes, also in really visible places and areas. And basically, people are not too, let's say, they do not look at that and saying, oh, that camera, why do they put that? It's not beautiful. They ruin the environment. So we are also developing this new, let's say, fully hardware solutions with this guy. To all the people that we are showing it, we are receiving a lot of interest. So I think we will see in the future more and more technical solutions that will have to pay attention to design. We will be filled in the next years with these devices, and I don't think anyone wants cities to be filled with ugly cameras. And so we are trying to fix also this.
Yes, we want to sell it also to art galleries.
Exactly.
Functional piece of art.
Terrific. Thank you so much, Tommaso and Marco, for sharing your expertise. It has been super interesting to learn about vision systems and artificial intelligence and the different projects you have already realized. Keep it up. I hope to hear from you again soon and maybe have you again on the show to talk more about use cases and exciting projects you realized. Thank you for listening to We Talk IoT. Until next time, stay curious and keep innovating.
Thank you.
Thank you.